That's close enough. That's probably it. You're going to have orange as the ground. The black's going to be the highest impedance setting. The green's going to be half of that. And the yellow's going to be half of that. If this is a 16 ohm transformer, this would be 16, this would be 8, this would be 4. Now in order to double check it, let's check it with our variac and we'll put some voltage on it and see what we get. We'll hook the variac up to the primary of the transformer much in the same way as we did the test on the Fender and the Marshall transformer earlier. I'll just simply hook up the variac to this primary. We'll hook one end to the blue, one end to the brown, and we're just going to ignore the center tap. You hook the variac up end to end, not to the center tap. We'll hook up the meter to monitor the variac voltage, just like we did on the transformers earlier. Okay, let's set our meter up to measure volts. And I'll set this one in the 20 volt range. This one is going to go across the secondary, orange, which we think is ground, and black, which we think is 16 ohms. We'll turn this meter on and we'll set it to the 2 volt AC volt range. Now we're going to give our variac some voltage until we see a half a volt on our secondary. So I'm turning this on and let's get it set for a half a volt. There we go. That's pretty close right there. We've got 0.501, about a half a volt. And in order to get that half a volt, we had to put 7.172 volts on the primary. So we take the that's down to 7 point, we'll call it 7.18. We take the 7.18 times 2, and we see that this is a 14.36 to 1 turns ratio output transformer when we use the highest speaker impedance setting. We take that and square it and multiply that times 16 ohms that we think it is, and we see that it comes to 3,299 ohms. Now that's within 10% of a 3,500 ohm transformer, which is what this is starting to look like. Looks to me like this might be a 50 watt Marshall style transformer with a 16, an 8 ohm, and a 4 ohm tap on it. But just to check that further, let's go ahead and take the one that we think is the 8 ohm tap and do some tests on it. I'll turn my variac off and we'll move to what we think is the 8 ohm setting, which is the green wire. We'll turn on the variac and we'll adjust the variac for 0.5 volts like we did earlier, so that we see 0.5 coming out of the secondary of the transformer. In other words, the 8 ohm tap, if that's what it is. There we go. That's getting close. You can see that in order to get a half a volt on the secondary, it takes about 10.36 volts on the primary. So we're going to use 10.36. So we take the 10.36 and multiply it times 2, and we see this is about a 20.72 to 1 turns ratio when we're hooked up to the green and orange output wires. Take that and square it, and then multiply that times 8, which is what we think it is, an 8 ohm setting, and we see that we get 3,434 ohms. So yes, that would be the 8 ohm tap. And then of course your yellow is probably the 4 ohm tap. We'll go ahead and turn the variac off, hook up the yellow, turn the variac back on, set it till we see a half a volt on our secondary. And it's coming. It's almost there. There we go. There we go. Yeah, there's our 0.5. And we see in order to get the 0.5, it took 14.38, we'll call it 14.4 volts to get that half a volt on that secondary. 14.4 times 2, that means it's a 28.8 to 1 turns ratio. We take that and square it and get 829.44, and then we multiply that times, we think it's 4 ohms, multiply it times 4, and we say that comes out to 3,317 ohms. So I would say that this transformer would work fine for a pair of EL34s going into either 16, 8, or 4 ohms.